problem 15.3. So consider the problem of minimizing the sum of these absolute values under the constraint ax equals to b. And we know that all these CIs are non-zeros, and we want to convert this problem into the standard form of linear program. Okay, so this constraint is okay. It's already linear, but this objective function is not written in a straightforward linear function of x. Okay, and we know that for this kind of things, a very common trick is that you split this x1. So you write x1 as x1 plus minus x1 minus. Okay, so in this case, both of these two numbers are greater than or equal to 0. Okay, so kind of substitute this as any number, real number, as a difference of two non-negative numbers. Okay, so now the x1 absolute value will be just equal to the x1 plus x1 minus. Okay, so the reason of this is actually the x1 plus is equal to the maximum of x1 0, and the x1 minus is actually negative of mean x1 0. Okay, so essentially it just means that x1 is equal to x1 plus is equal to x1 if x1 is positive, and x1 minus is equal to negative x1 if x1 is negative. Okay, just take, so it's like the x1 plus x1 minus are the absolute values of x1 depending on the sign of x1. Okay, so you can do that. So now you can replace this by the x1 plus minus x1 plus x1 minus, right? So let me see. So I should have positive right here. Okay, see it. So all those things are positive. So now you can rewrite this objective function in that way. But now since we replaced x with the positive negatives, so this ax will become, remember that it's a of x1 plus minus x1 minus, right? For the x1. So here, x1 xn equals to that. But for x1, we have rewritten that into this form. Okay, and also the others are xn plus minus xn minus. Okay, so you can think of this as the a times x1 plus all the way to xn plus minus a times x1 minus all the way to xn minus, right? Or if you like, you can write this as a negative a. So now this matrix is n by 2n. And here you concatenate these positive and negative, so x1 plus all the way to xn plus, and then x1 negative all the way to xn negative. So basically you stack these two vertically, and then you stack these two matrices horizontally. So you can see that this is still true. Okay? So the ax essentially just becomes this, and this is equal to b. Okay, that's how you form this into a standard form of linear program.